Good morning, everyone. At least it's morning in my house. It is week 5 of the shutdown, and this week we are going to start what is called the Wilcoxon Rank Sum Test, abbreviated WRST. I posted the note sheet for it. I posted the form that you fill out, the outline for it. It doesn't really require a table. It's going to go back to the Z table, and I'm just going to give you the critical values, the alphas for the 0.05, 0.01, and 0.10. Even though we're doing non-parametric data sets, we do try to, not using the data, but for the first time, we're going to rank the data, and we're going to use the ranks to try to normalize it and get to find a mu, to find a sigma, and kind of fit it into what's called a z-test that we did before. Now, before we get to that, you'll notice that I have up on the screen, this is number 6. Thank you for everyone that did the sign test and the paired sign test that you handed in last week. Last week was a pretty easy week. You know, you didn't need a calculator, didn't have to add anything in, no long complicated formulas. It was simply, you know, find a sign, count the signs. So even those people that have had problems with calculators, you didn't even need a calculator for the sign test. You will for this one. You don't, actually you could do it without. The calculator just makes it easier to sort the data, but it's very possible to do this test and probably the rest of them without a calculator. The calculator makes it easier, but you could do this with a for function if you just with a calculator on your phone, with just the one that normally comes with it, not one that you have to download. But before I get to that, the only issue that I saw, and I think I mentioned this if I emailed you back with your grade, I also updated grades. Well, I lied. I didn't put this one in yet, but grades are due for third quarter. I have to have them in, I believe, by Friday. So today and tomorrow I'm going to be working on grades. So continue to check eSchool, and if you did something and emailed it to me, because my email's a mess with, you know, a gazillion people that are taking pictures and sending them to me. So if I missed something, just let me know. Say, hey, I handed this in. You know, I don't see it in eSchool. There's still a little exclamation point. And just let me know if I don't have something in eSchool that you know you did. Now, the only thing I saw on the sign test was on number 6, where they said an athletic director suggests the median number of paid attendance is 3,000. That's his claim. He's saying, I believe the median number of paid attendance at my 20 football games is 3,000. And then it said here, is there enough evidence to reject the claim? And most people's conclusion was you had enough evidence to support the claim. But they didn't ask us that. So your conclusion should have been, because we did not reject HO, we do not have enough evidence to reject the claim that the paid attendance for his football games is 3,000. And then very few people answered the following question. If you're printing programs for the games, would you use this figure as a guide? Now this turned out to be, we didn't reject this, so we believe this is the median. So therefore, I would use that as a guide. Now if we rejected that and that wasn't the median, it wouldn't be helpful. But the median tells us that at each game you should expect to see somewhere around 3,000. And that the fact that we did not reject it makes it a good number to use as we do that. Okay, now moving forward, remember I'm not doing the whole test today. We're just going to do a couple pieces because this next test is a little complicated. But it is called the Wilcoxon Rank Sum Test. Because this data is not normally distributed, we work with the ranks, not the data values. We will originally put the data values in our calculator and sort them, and that makes ranking them easy. But once the numbers, the data, are in order and ranked, we don't need the data anymore. So now let me put in here, and I might have gone through some of this. These are my notes that as I was doing this, I just kind of jotted down. So this is the Wilcoxon rank sum test. Wilcoxon is the statistician / mathematician that developed this test. It is the non-parametric partner to the two-sample t-test. I don't know if you remember, and this is independent data because we're going to compare males and females, and those are two separate groups. There's no overlapping, so that makes them independent. It's a t-test because we're going to have less than 30 numbers. And then all of the tests going forward, we're going to work with small samples because we can't just put them in a calculator and have the calculator do the test. We have to do it by hand using formulas. We stick with small sample sizes. Now, it isn't, if you recall, the two-sample t-test we did before had two pieces. We had to do the f-test first, and then we did the two t-test. This, because it's non-parametric, it doesn't have a standard deviation. We don't have to worry about the f-test. We just put them in. We don't have to worry about pooling or non-pooling. We're just throwing the data in, and we are going to work with the ranks of the data, not the data values. And because the data is not normally, there is an LY, they're normally distributed. Now, because it isn't normally distributed, remember in a normal t-test, we would have mu1 equals mu2 and mu1 doesn't equal 2. But because it isn't normally distributed, we can't use the term mu. So this problem, let me show you at least what we're looking at. And to show you everything here, I had to tweak some of the data. And I'm going to try to take pictures instead of the whole page of just specific problems so that you get a better look at it. Because I know sometimes it's a little blurry when you look at the whole page and try to zoom in. But this is a test dealing with the lengths of prison sentences. And they wanted to see if there's a difference. Are male prison sentences, the length different from females? Now watch this data because the males are here and they continue here. So there should be 12 prison sentences for males and 14 for females. Now, so that I could show you how to rank them in cases where we have repeated data values, I changed this data value to 12 and I changed these two data values to 4. So when you put them in your calculator, these are all the males. The two top lines are males. Use the 12, not the, I can't even see, I think there was a 14 there that I crossed out. And use these two 4s for the females, not the ones that are listed. It appears as though this is going to be a, where is it? Two-tailed test. So that's, and the alpha is 0.05. We won't need that for a while, but just to keep that in mind. So because it's talking about prison sentences, I had to put here no difference. This is if they're both equal. If the length of prison sentences for males and females are the same, then there's no difference in prison terms based on gender. And then for H1, you don't have to repeat all of this. You just have to say there is a difference. And then you're going to enter the data into two separate lists. Because they're independent, you can't combine them. Once you have, like I put males in L1, make sure there's 12 numbers there. I put females in list 2, make sure there's 14. And then once you've done that, you are going to go to stat, and then you are going to sort them. And remember, when you sort them, you have to tell the calculator what list to sort. So you are going to sort L1. If you don't have a graphing calculator, then you would just have to look at those numbers and like sort them yourselves from small to large. And then if you hit enter, it'll tell you it's done. And then you will go look. Here I did this kind of complicated so that I could sort of show you both the data and the ranks and do some stuff. So don't look at this quite yet. But please be careful to check your data values before you sort them. I put the data values in each list, and then I go back and check to make sure the data values are right, and then you sort them. because once they're sorted, if you have a data entry problem, if you typed a number in wrong, it's much harder to find it once they're sorted. So here is the data for the males that are sorted. I put them all in one line. This is the data, and here's the data for females. Now, normally you wouldn't have to write the data down, but I did it here just to show you so that we could see an example. Now, this is the data. Now we're going to rank them. So when we rank them, 6 is the smallest number, it gets a rank of 2, or a rank of 1. 8 is the second smallest, it gets a rank of 2. Now, if you have repeated letters, these two 12s should be a rank of 3 and 4. What you do is you take the average of those ranks, which is 3.5, and you give them both the same rank. Both of those 12s got a rank of 3.5. Now they shared. This is them sharing rank 3 and rank 4, and then you pick up rank 5, 6, 7, 8, 9, 10, and you should finish, because there's 12 pieces of data in L1, which are males. There's 12 prison sentences for males, and I put that down here. Make sure the last rank should be the sample size. And you'll notice I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then we do the same thing for females. 3 is the smallest, it gets a rank of 1. Now there's 3 4s. So if these are 3 different numbers, this is ranked 2, 3, and 4. We take those 3 numbers, 2, 3, and 4, average them. Should come as no surprise that the average is the number in the middle. So those 3 numbers, all 3 of those 4s, since they're the same, get the same rank. Now, if they were different, they would be ranked 2, 3, 4, and then you would pick up with 5. This is 6, 7, 8, 9, 10, 11, 12, 13, and 14. There's 14 females. I wanted to fit it across so I didn't have to do it in 2 rows to make it look a little nicer. Now, that's probably the hardest part of the whole thing. And it's not really hard, it's just kind of cumbersome. Now you have 2 ranks, males and females. So R1 is males, I have 12 of them, sample size 1. R2 is females, sample size 2. Now there's 3 formulas that we are going to have to use for this test. And those 3 formulas, one of them is we're going to need to find R. This is R1, this is R2. We only find R, which is the sum of the ranks for one of these ranks. We do not find the sum of both of them. And the one we find the sum of is the smaller sample size. So because I have less males, I'm going to take these ranks right here, which I wrote here, all these ranks right here. Where are they? Right here. Here are the males, and these are these numbers that I'm writing down here. Here are my ranks. 1, 2, I don't know if you can hear it, my phone's ringing in the distance, but that's okay. It's, you guys are way more important than anybody that might be calling me. So you just put all your ranks in a list and add them up. I got 78. Now, because I changed the data, I can't look in the back of the book and make sure that my answer is right. So your job for today and tomorrow is to read over this and make sure that what I did here was right, and make sure that you get a rank of 78, that these numbers add up to 78. If you get something different, let me know. Say, hey, my ranks added up to 79. I know the numbers here, these ranks are right. And just make sure, if you see that I made some blatant kind of error, because it is Monday, it is still in the AM here, just let me know. Now, this is the first couple steps. And I have a meeting in 15 minutes. So I thought this was enough for you to kind of take a look at and peruse and kind of think about over the next couple days. So I will post again another video tomorrow, and we will finish up this test, and I'll see you soon. Hope you guys all had a nice Easter. Take care. Bye.